Welcome back to a new video. In this video, we are going to do data cleaning on a real-world dataset using Python Pandas. The dataset is going to be about online food orders, and I'm going to add the dataset's link in the description of this video. Let's start coding. Okay, so this is the data that we are going to use for the data cleaning in this video, and I'm going to leave this link in the description of this video. You can download it and use the codes that I use in your computer. So we have the online food dataset, and the dataset contains information collected from an online food ordering platform over a period of time. It encompasses various attributes related to occupation, family size, feedback, etc. And we had attributes. We are going to check the column list in the code editor, so I'm not going to read all of them. And here's what our data looks like. So, okay, just download the data and put it in the same directory where you are going to create your Python file or Jupyter notebook, and we are ready to go. I'm going to re-record in the code editor. So we are in the code editor right now. I'm going to use Visual Studio Code, but you can use PyCharm, Google Colab, Spider, anything you want, it doesn't matter. And in here you can see my dataset is in here. I downloaded it and transferred it to here. So I'm going to create something like notebook.ipmb. And in my Jupyter notebook, I'm going to select the kernel, Python 3.11.4, and I'm going to say at the first place, import pandas as PD. So sometimes with time, libraries can change, codes can change. So I'm going to give you my pandas version like this. I need to use PD since we imported as PD, and it's 3.0.3. So if a code in this video is not working in your local computer and you want to make them work, you can just say from terminal pip install and you can specify pandas version like this. And if you do that, you are going to see that when you rerun this, you are going to have the pandas with the same version I have, and the codes are going to be working in your computer. Okay, after this, we can just do something like this, and then I'm going to start to my video with, I will say data, and I will use pandas read CSV, and I'm going to save my data on this data, and I will just do this, and I'm going to make it run. Okay, we uploaded our data. Let's check if it's loaded successfully. We will say data.head for seeing the first 5 rows of the dataset. Also, you can specify the number in here. For displaying the row number that you want, you can just write 2 if you want to see the first 2 rows, and you can just use tail for seeing the last 2. Also, you can just delete, it's defaultly 5, and I'm going to say head, and let's talk about this. So we have age with integer data type, gender with string data type, marital status with string data type, occupation with string data type, monthly income with string data type, educational qualifications with string data type, family size with integer data type, and latitude, longitude, pin code with integer data types. I'm sorry, these 2 are floats. Let's quickly check. I will say data, and I'm going to filter the data latitude, and I'm going to say the first one. Also, you can see in here, it says float, but I'm going to show you a different thing. I'm going to select a random one in here. I'm going to pick this one, like in here, and I will say type. So I'm going to see its data type. Okay, it's float. I'm just going to clear the cell output, and we have output with string data type, feedback with string, and unnamed 12 with strings. So, okay, the next step is going to be doing data.shape for seeing the row and column count. It says we have 13 columns in our dataset and 388 rows. So I will just write data.info, which gives general information about the data types, memory usage, range index, and we can see the non-null counts in here, data types, and range index. Also, we have memory usage in here. Great, so we can start to cleaning our data right now. I have a checklist. I'm just going to copy that and paste it in here. So deleting redundant columns, renaming the columns, dropping duplicates, remove the NA values from the dataset, and check for some more transformations. We are going to go over data cleaning list one by one. Like, we can just say data cleaning list, and let's go one by one in here. So we will start by deleting redundant columns. There are two ways of it. I'm going to show you the both. You can either drop the columns that you don't want to use, or you can filter the rows that you want to use. So I'm just going to call data head1, and I will call data.columns for seeing the exact column names. And I'm going to create two lists in here, like columns to keep and columns to drop. So they are going to be both lists, and let's see. I'm going to pick age, gender, marital status, occupation, monthly income, education qualifications, family size in the columns to keep, like this. And there's a problem with the bracket, so yeah, I need to put this one in here too. So it's fixed now, and I'm not going to take latitude, longitude, pin code, and I'm not going to take these ones. Also, I'm not going to take unnamed 12 thing in here, and I'm going to take output and feedback to columns to keep. So we created these two lists, and we had 13 columns. Let's check the length of the columns to keep. It's 9, so we are going to drop 4 columns. Columns to drop is going to be 4. Great. So I'm going to recall the data, and I will start with the first method, filtering the columns that we want. So how we can do that is we can select a column in a data frame. Like, let's say I want to get this family size. If I do family size like this, it's going to return me a series data frame, and I got a single column like this. But if I give 2 brackets in here, it's going to give it to me like this. Also, I'm going to say, I remember like we have age 2. I'm going to say age like this, and I'm going to pick these 2 columns. You can see we have age and family size in here in a new data frame. But what happens if I delete one of the brackets? So I will have here, but if I just try to select one, I'm not going to get an error. Okay, so since we are going to pass a list inside of this, we are also going to have the brackets, so we can just use data columns to keep, and we will see that we have a new data frame with the columns we want. But there's a problem. We filtered it, but when we call the data again in somewhere else, you are going to see we are going to have the columns that we don't want, because we didn't modify the data frame we are using. We can just create something like modified data, and if you call the modified data from now on, we are going to have the data frame that we want. Great. So this is the first way of it. Let's go with the second way. I will say second way, dropping the unnecessary columns. So how we can do that is I'm just going to call the data again, and we can say data.drop, and we are going to specify columns like this, and we can just give a list. Like, let's say we want to drop the age, we can just say data columns age, and you can see the age column is deleted. So we are just going to give the columns to drop list in here, and we are going to have the data frame that we want. I showed you how we can set the data frame, but in here I'm going to show you a different method for that. I can say in place equals to true, and it's going to just save the new data frame in the data. So it's going to modify the original data frame. I'm just going to cut this for now, and I'm going to make it run. This is the data frame that I want, so I can just say in place equals to true, but before running this cell, I'm just going to run the data in here, and you are going to see that we have the columns that we don't want. So I'm just going to make this run again, and then I'm going to call the data, and we have the data frame that we want on the data. Great. So that was the first thing that we are going to do, and I'm just going to call this again. So the second step is renaming the columns. So let's go with that. I'm going to call the data.columns. Also, I'm just going to change this to data head 1. So let's see what we can change. So let's change monthly income to monthly salary. So how we can do that is I'm just going to say data.rename, and I'm going to specify columns like this, and in here we need to give a dictionary with old column name at the first place, like monthly income, and a new one at the second place. For example, you can just say A, and it's going to change it to A. And we are going to give monthly salary, and I'm going to make it run. But still, it's not going to modify the original data frame, since we didn't set it. Like you can see, it's monthly income right now, but in here it's monthly salary. So you can give in place equals to true in here. Great. So I'm just going to call the data again, and it's monthly salary right now. It's updated. Great. So I'm just going to recall the list we have, and okay, we have renaming the columns completed, and the next step is dropping the duplicates. So I'm going to make the data.duplicated run, and we are going to have booleans like true, false, and we can see true, and it returns a series, so you can easily manipulate that. Like you can use value counts, and you can see the true count. We have 144 duplicated, and you can just use head on this. Like, before using it, let me delete it. Firstly, you can see I'm going to use head, and you can check the first 5 if they are duplicated, or let's say last 50 if they are duplicated or not. But what I generally do is I just use in here that sum and get the general count. It's 144. So how we can drop that? We can just say data drop duplicates, and for setting it we can say in place equals to true, and after this we can call data duplicated sum, and we are going to see that we are not going to have any more duplicates in our data set. So we have another task completed. I'm going to recreate this. The next step is removing the NA values from the data set. So for that we are going to call data.isNA, and it's going to return booleans cell-wise like true and false, and we can just use that sum for seeing it column-wise. And we don't have any NA value rows, so what I'm going to do in here is I'm going to show you the code for deleting them. If you have in your data set, like for the future users, you can just say drop NA, and you can use in place equals to true. And after running this code, you are not going to have any duplicates. Also, you can check if you have after this, like that. Great. So also there's other methods for filling the NA value rows, like if they're integer, you can just use or median for filling, or you can use interpolation, and you can use backward fill, forward fill. There's a lot of options on NA filling side. It depends on your data set, and if you have text values, you can just change them with the most occurring value. You have a lot of options on the filling NA side, but for the duplicate side, we don't have a lot of choice. We generally delete the duplicates. Okay, I'm going to get my checklist back, and we are at the last step. Check for some more transformations. So let's do that. Let's see our data. Let's start with this age column. So let's say we want to have the age in months, not in years. So this is 20 years, but how much months? We can just create something like age but months as a new column, and we can just set data age multiplied by 12, since there's 12 months in a year, and we can just create it. And I'm going to check it, like we have age months in here. Great. So let's keep with gender. Let's say we don't want this entire text for female and male. We want only F if the value is female, and we only want to M if the value is male. So how we can do that is I'm going to call the gender column like this, and I'm going to say dot apply. I will use lambda x is going to be F if x is equals to female, else M, like this. And we are going to have the series that we want, but I'm just going to call the data again. It's not modified. So how we can modify this is we can just do data gender like this, and we can just set it like this. And whenever I call the data again, we are going to see it's changed. Great. So let's do more. Let's change the family size. Like we are going to say if, let's create a logic firstly and use data.head 2 in here. Let's say if family size is greater than 3, it's going to be small, else it's going to be a large family, else small. So let's do that. We will say data family size dot apply lambda x large if x is greater than 3, else small. And again we have the data we wanted, and we can just save it like data family size, and we are going to have the data we wanted in the family size. Great. Also let's do one more. Let's say we want this output to be 1 if we wanted it to be used on the machine learning models, and no is going to be 0. So in machine learning model training side, you generally need to have numbers, not the text. So how we can do that is we can just filter the data output, and we can use that apply again. We will say lambda, there's 3 p's, so let me quickly delete one. Lambda x is going to be 1 if x equals to yes, else 0. So when we do that and we save it as data output like this, we are going to have the data we want. Great. So it's in here. Okay. Also what we can do is we can change this data type, like we want floats in here. Let's say we want floats in output. So we can just do data output dot s type float, and we will see we have floats. We can just use data output, and we can save it like this. Great. So I think it's float right now. Great. And I'm going to call the checklist again, and we completed our list. Great. So the last step is you need to export this data frame that you cleaned. So how you can do that is you can just use the prebuilt functions in Pandas like to Excel, and you can just say cleaned data.xlsx, and you can specify the index true or false. Index is this one. I generally prefer index equals to false, and you can just export it like that, and you are going to see that in here like this. Also you can do data to CSV, and you can export it as a CSV file. You can say cleaned CSV, and you can just use .csv, and we didn't specify the index. It's defaultly true, so it just, I'm going to show you, clean CSV.csv is in here. So I'm just going to say pandas with CSV, and I will say clean CSV. You are going to see that we have the index column in here. You can delete it or not, it's up to you. Since we dropped the duplicates, these indexes are shifted. So also let me quickly show you how we can fix that. I'm going to call the data. You will see that this index is just unrelated since we only have 243 rows. So 244 rows, I'm sorry. So what we are going to do is I'm going to say data reset index, and after that I'm going to have this, and I will say drop the old index list. So I will say drop columns, and I will say index. So we are going to have the data frame that we wanted. Also, we can just use data equals to this, and our new data frame will have the indexes that we wanted. So let's also redo the operation CSV part. So I'm going to come back to here, and I will say data to CSV, then I will say clean CSV, and we have the index numbers that we want right now. Great. So it was all for the video. Before the outro, I'll be really happy if you can leave a like to this video, and thanks for watching. Let's get to the outro. Thanks for watching the video. I'm sharing 2 or 3 new videos every week about data science and Python programming. You can subscribe to my channel for more videos like this. I shared a free data science bootcamp where I teach Python, Pandas, NumPy, Matplotlib, Plotly, Seaborn, and scikit-learn with 3 projects. The video is about 7 hours and it's completely free. You can just reach to that video from the card of this video or the link in the description.